Hello, wonderful students. It's Mrs. Bodell again. We're plugging along in Chapter 12. We're on Chapter 12, Lesson 3, page number 915 in our book. You guys, we are almost finishing with this book. We're in the last chapter of our math book, which is amazing. And we are, if you see this plane that says peanuts or pretzels, you know you're on the right page. Today we're going to be classifying triangles, and let's get started. It says you can classify triangles by using one or more of the following attributes. An attribute is a characteristic of something, like the side measures and angle measures. So let's take a look. The Hammond family, this is example 1. The Hammond family traveled from Columbus, Ohio to Dallas, Texas, and then to Atlanta, Georgia before returning home. The distance of each flight is shown on the map. So let's see, they started in Columbus, Ohio, and flew to Dallas, Texas, then to Atlanta, and then flew home. And the distance of that flight, of those miles, is on the map. So this distance here was 924, then 729 miles, then 573. Find the number of congruent sides. So the lengths of the sides of the triangle are 924, it's got that one, 573, and the one that's missing is there, 729 miles. How many sides of the triangle are congruent? And remember, congruent means equal in length. How many sides are congruent? None of them are congruent. They're all different. So let's look at this key concept, and we're going to have to probably come back to this page a few times. Here's 3 different types of triangles. An isosceles triangle, and that's spelled I-S-O-S-C-E-L-E-S, and it's pronounced isosceles triangle, an equilateral triangle, and a scalene triangle. Isosceles, equilateral, and scalene. So isosceles has at least 2 sides congruent. So notice we've got the 3 and the 3. So 2 sides are congruent. It's isosceles. Equilateral, notice that beginning that kind of looks like equal. All of the sides are congruent. And scalene has no sides congruent, 2, 3, and 4. Notice that. So based on this that we've learned, and no sides are congruent, this triangle on the map up there is a scalene triangle. Scalene triangle. So keep your hand on this page because we are going to have to come back to it. Okay, let's turn the page. It says, triangles form the sides of the Khafre, I need to look that up, pyramid in Egypt. Determine the number of acute, obtuse, or right angles. So we would have to measure them. So this one is like 55 maybe. And this one is 75, and this one is 55. So how many of the angles are acute? Remember, acute is less than 90 degrees. They're so cute, little tiny angles. Obtuse is like obese, big fat angles above 90, and then right angles are exactly 90 degrees. So how many of them are acute? 1, 2, 3, all of them. How many are obtuse? None of them. And how many are right angles? None of them. And here's another way to classify triangles by their angles. So an acute triangle has 3 acute angles. A right triangle has 1 right and 2 acute angles. An obtuse has 1 obtuse angle. You will never see a triangle with more than 1 obtuse angle, because once you get that size of angles you can't form together to make a triangle. It wouldn't close. So based on this information, the triangle in this example, it has 3 acute angles, so it is an acute triangle. It is an acute triangle. Okay, let's do the guided practice. Classify the triangle based on its sides. So based on its sides is what we're looking at here. We either have isosceles with 2 sides congruent, equilateral with all 3, or scalene with none. So we've got, let's see, we have 4 centimeters, 2 centimeters, 2. So how many sides of the triangle are congruent? 2. And we look back at our thing, and if 2 sides are congruent, it is an isosceles triangle. And we're going to spell this correctly. It's I-S-O-S-C-E-L-E-S. The triangle is an isosceles. And that's an I, capital I, isosceles. And then if we could classify this based on its angles, we have to measure the angles. I will measure them for you. If you don't have 65 degrees, a protractor, 80 degrees, and oops, wrong way, Mrs. Bodell. Mrs. Bodell went the wrong way. Let's see, we can do that. 40 degrees. 35 actually. Okay, so all 3 are less than 90. They're all 3 cute little angles, so it is an acute triangle. Isn't it cute? Now, it doesn't matter if that triangle is giant. If the angles are that size, it's an acute triangle. Okay, talk math is to describe an isosceles right triangle. Well, an isosceles triangle has 2 congruent sides. So I've got 2 congruent sides and a right angle. This side is equal to that side, and it has a right angle. That is a right isosceles triangle. Okay, let's go to the independent practice page. It says determine the number of congruent sides and then classify the triangle based on its sides. So let's see, 2.9, 2.5, and 2.3. So there are 0 congruent sides. We look back at our thing. Which triangle has 0 congruent sides? The scalene. So this is a scalene triangle. Okay, let's look at number 4. I've got 2 and 2 and 1.5. So 2 are the same. That makes it an isosceles triangle. Isosceles triangle. It has 2 congruent sides.
The drawback in that schedule to me is that having less people in online classes.
Okay, for problems 5 through 6, well, 5 through 8, actually, we're going to do it by its angles. Now, this one has that square, and remember, I told you that square means it has a right angle, so it is automatically a right triangle. Okay, we've got a right triangle. And then let's do some measuring here. We've got about 105. Oh my goodness, this is 105 degrees. I already have an obtuse angle. And so if I just spilled my water, sorry. Let me pause it. I've spilled my water. Okay, you guys, I spilled my water all over my table, but I think I fixed it, and I don't think anything is broken, so that's good. Okay, anytime we have at least one obtuse angle, it's an obtuse triangle. So we don't even have to measure the rest of them.
I think that's a good point.
Okay, let's look at number 6. Let's look at number 6. I've got this here, and that's about 70 degrees. And then I've got this angle here, which is 70 degrees. And this angle here, which is 40 degrees. And so it's not obtuse. None of the angles are obtuse. It's not a right triangle. It doesn't have any right angles. And so the only thing it can be then is an acute triangle. It has 3 acute angles. All the angles are less than 90. Oops, not acute angles, acute triangle. And then the last one on here, and if you've noticed these two are the same, what you would learn later in geometry is that because these two angles are the same, the sides must be the same. So it is also an isosceles triangle, but we're not measuring by the sides right now. We're just doing length. Okay, so I thought that was going to be 60, and then I'm guessing this is also 60 because it looks to me like an equilateral triangle on sides. And so as far as classifying by angles, it's not obtuse. All the angles are less than 90. It's not right. It does not have a right angle, so it's acute. It's an acute triangle. They're all less than 90 degrees. Okay, draw each triangle. Draw an equilateral triangle. That means all 3 sides are equal. It's also a regular triangle, if you remember. And as I said, so all 3 sides are equal. And as you will learn in geometry, that also means that all of the angles are equal. So it's going to be that one. A right triangle has to have a right angle, which is that 90-degree angle that you make when you go like this with your hand. It's like straight, or this way. It's this straight angle here, like 2 perpendicular lines coming together. And there's a right triangle. Okay. And then, here we go. Let's do this problem solving. Question number 11 says, half of a rectangular sandwich looks like a triangle. That's true. Classify it based on its angles. So if we have a rectangle and we cut it in half, rectangles have right angles. So that means that this triangle still, like this triangle piece that I cut out, still has a right angle. So it is a right triangle.
Some of my sophomores, and I just thought it was really interesting. These are the sophomores that came back.
Measure the sides of the sandwich. Classify the triangle based on its sides. Well, I lost my tape measure in the water disaster spilling, and so I can't measure it. So I'm just going to skip question number 12. If you want to do that on your own, you can. Draw a conclusion. Hot problems. Emma, Gabriel, Jorge, and Michaela each drew a different triangle. Use the clues below to describe each person's triangle as isosceles, equilateral, or scalene, and also acute, right, or obtuse. So Gabriel and Jorge each drew a 90-degree angle in their triangle. So I'm going to write Gabriel, Jorge. I don't know where you're supposed to put all these answers.
Maybe then they're going to try and do a parent survey and a student survey, because I'm really curious.
We know that they each had a 90-degree angle. So if it has a 90-degree angle, it is a right triangle. If it has a 90-degree angle, it is a right triangle. So we can write down that both Gabriel and Jorge have right triangles. But we're gonna leave a space because we don't know if it's isosceles, equilateral, or scalene. Okay, who else do we have? Emma. One of Emma's angles measures greater than 90. Ooh, if it measures greater than 90, we know it's an obtuse triangle. And then who's the other person? Michaela. So we don't know anything about her yet. Okay, each side of Michaela's triangle and 2 sides of Emma's and Jorge's are 4 centimeters long. So Michaela has one that's 4, 4, and 4. So we know that Michaela's has to be an equilateral triangle. Equilateral. And because those angles have to be equal, we know that it's also an acute, equilateral acute triangle. Those angles are all 60 degrees. When we have an equilateral triangle, all the angles are 60 degrees. So they're all less than 90, they're acute. Okay, each of Michaela's sides, each side of Michaela's triangle, we're done with Michaela. 2 sides of Emma's and Jorge's. Okay, Emma has 2 sides that are 4 centimeters long. She's got that obtuse, that big angle. So she has an obtuse isosceles. 2 sides are the same. An isosceles, an obtuse isosceles triangle. 2 sides of Jorge's are the same. Remember, he's got the right angle, but then 2 sides are the same. So this one's 4 and this one's 4. So he has a right isosceles triangle. And we don't know anything else about Gabriel's. I skipped this one. Gabriel's triangle does not have any congruent sides. So Gabriel has a right angle, but everything else is all different. So his is a right scalene when none of the sides are the same. Okay, great work, my friends. Keep it up. Have a good day.